And pause. Good afternoon, everyone, and welcome to this afternoon's CPD session with ARPAS-UK in conjunction with Connected Places Catapult. This session will be covering survey accuracy utilising drones, and we're delighted to have Ben Craigie and Harry Atkinson from Sensat here to take us through this. For the moment, just a couple of housekeeping issues. The session, as you will have heard, will be recorded, so please keep your cameras off and stay muted. If you need to contact us afterwards, we can be contacted via email on membership@arpas.uk, and I know Harry and Ben have added their email and phone details to the session as well. So they are always contactable, and ditto, we can send them any questions on to them. Please do ask questions via the Q&A function, and I believe Harry and Ben will attempt to answer those questions as they go along. Okay, so a little bit about Harry and Ben. Harry is a technology entrepreneur with years of experience commercializing products and services. He co-founded Sensat in 2015, so relatively early on in the drone world, with the aim to digitize the world, enabling the next wave of technology to help integrate with the world around us. His role at Sensat is the creation and delivery of Sensat's new data products and services. He has extensive UAS experience conducting operations globally. In 2017 and 18, Harry led Sensat's BB-Loss project in conjunction with Costain and the Transport Systems Catapult, trialling the use of BB-Loss over live construction projects up to 12 kilometers. Ben is the survey manager at Sensat and has spent over 20 years in the field as a surveyor, moving with the progression of total station development, GNSS advances, laser scanning and CAD modelling before latterly moving into a management role. 3 years ago, Ben became a full member of the Chartered Institution of Civil Engineering Surveyors and more recently joined Sensat as survey manager. Here, he works to ensure Sensat meet expected standards, monitors and looks to improve overall accuracy while liaising with clients and taking responsibility for the final data deliveries. So welcome to all our attendees and also to this morning's presenters. Thank you very much, Ben and Harry. I'm going to hand over to you now and put myself on mute and stop my video too.
Thank you very much, Eleanor. Yeah, and welcome to everyone. Good afternoon. And yeah, thank you for joining this afternoon session. Excited to be here and share some of our thoughts on drone accuracy and what can be done with them in 2022 and beyond. So as I said, my name's Harry. We've also got Ben with me. I'm the co-founder of Sensat, and Ben is the survey manager at Sensat. So just run you through today's agenda. So we're going to start off with like where are we now, sort of the current state of play with drones and what can be achieved with them, and the sort of progression through from the early days to where we are today and beyond. We're going to say how accurate you can get with drones. So Ben will take us through that. He'll also take us through the techniques required to ensure accuracy. I will then take you through some future opportunities for drones, and then finish with a demo of the Sensat platform, and then field any further questions that you guys may have. As Eleanor said, Ben and I will be monitoring the Q&A section throughout, and if there is a relevant question to what we're talking about, we will disturb each other and try and ask it as we go, because I think it's better to be a bit interactive with these sessions. And yeah, the aim of the sort of session is to get everyone to understand how accurate we can get, and obviously how we can be safer, faster and quicker with a greater level of accuracy going into the future. So I'll just start off with a bit about Sensat. So for those of you who haven't heard of Sensat, we're a technology startup founded in 2015 with the aim of digitizing the world. And what that manifests itself in is that we want to reduce sort of the risk and improve sustainability within the civil engineering and construction sectors around the world. In the UK, we operate a large drone operations team who collect data on a daily basis for our clients. And we also have a technology platform which allows people to access that information. So where are we now? So I'll just take you through sort of the evolving technology landscape that's come about with the sort of advent of UAS or drone technology over the last sort of 7 or 8 years. So pre-2015 is what we term the pre-automation stage. So that was there or thereabouts the time DJI were being founded as well, or becoming sort of mass market globally. But this was really the period in which drones had to be manually operated and were not sort of automated in any way in terms of their data capture. They were also predominantly B2C products, so consumer products. And I think it was really interesting actually during the DJI presentation on Monday, which I'd encourage you all to go look at. They mentioned that the sort of enterprise sector really paved the way for the technology to be evolved by utilizing consumer-based products and essentially forcing them into a B2B setting through various different hacks and methodologies to essentially make them work. But during the pre-automation stage, data was very difficult to sort of collect reliably. You had to be very skilled, and you had to have a very detailed methodology and a very detailed sort of quality assessment and processing stages to be able to achieve sort of the levels of accuracy that were equivalent to what was being collected by surveyors and methodologies, and mistakes were easy to make. From 2015 to 2017, this is where we call the pre-specialism stage. So after 2015, automation started to come in. So that, by automation, I mean automatic flight plans, automatic flight paths. Users and operators were able to put in parameters which help them sort of guarantee sort of levels of detail or levels of reliability in the data. But the technology was still pre-specialism. So there really wasn't anything on the market that was dedicated towards surveying and mapping specifically. And by that, I mean, obviously the drones in terms of their capabilities, so their sort of speed, their flight heights, where they can fly, but also the payloads as well. From 2017 onwards, we started to see the introduction of RTK and PPK, which are both like GPS or global navigation system variants as standard. So what this enabled surveyors and people in the mapping industry to have is a much higher degree of accuracy straight off the bat with their data that's being collected. Previous to this, they had to rely on ground control points and then also standard sort of GPS accuracies to achieve their data quality outputs. What that meant is that data accuracy out of the drone went from around 3 to 5 meters down to 3 to 5 centimeters. So this was a really big change in the way people operated these drones and the effort that was required to get high accuracy outputs. With today, we're obviously using RTK and PPK as standard across most enterprise drones, and this essentially allows us to use slightly less ground control, but it also means that control can be used as verification, which Ben will go into later on in the presentation. So from 2017 to 2021, well, I guess 2021 and beyond, we have started to see specialist payloads dedicated to the applications that we are all interested here in this session. So that means the cameras, or further on in that cycle, the LiDAR units that were specifically designed for people like us to collect high accuracy data that was precise and reliable across multiple different like areas and time frames when you were collecting it. Again, what this allowed people like us to do is really hone in on what their I guess product market fit was, and also allow a higher degree of reliability to their clients. So instead of it being sort of a time frame of like maybe 4 weeks to get this captured and delivered, you can give more specific time frames and quality guarantees as well. And then 2022 and beyond, as I said, DJI just did their DJI Enterprise event for the year with some really sort of incredible innovations. One of them being the drone in a box solution, which in the future will essentially allow teams on construction and infrastructure sites to set up a box and have their site scanned on a regular basis without needing to put even a drone pilot on the ground. It could all be centrally managed from a separate location. So where we're seeing this technology move is further specialism of payloads, but also the sort of miniaturization of different technologies, particularly in the field of LiDAR and photogrammetry. We're seeing higher resolution cameras being fitted to smaller and smaller drones, which enable higher degrees of accuracy and reliability with less time spent in the field. So really exciting time to be in this industry and actually to be sort of innovating within it like Sensat are. And obviously what this all means and what the sort of aim of all of these innovations and changes are is that we're trying to get like good and accurate information to the end users and the end stakeholders as easily as possible in sort of an understandable way. So we're seeing today that users of this information are moving from sort of the more technical end of the spectrum down to the non-technical end of the spectrum, and enabling them to make decisions faster and reduce their risks on site. So I'm just going to run through a couple of remote sensing methodologies. So both passive and active remote sensing, and I'll just tell you the difference between the two and give you the examples of how they can be applied using UAVs. So the first one, which is sort of the most common form of remote sensing in the industry today, is photogrammetry. So essentially photogrammetry was developed during World War I actually to measure the depth of trenches. So you use stereoscopic vision to measure the depth of the trenches, but the technology's obviously come on a long way since then. And today we're using UAVs to collect images, so high degree of accuracy images with georeferencing and stitching them together to create 2D and 3D outputs, which are highly visual and accessible to pretty much all stakeholders. We see that drone photogrammetry delivers the sort of best balance between accuracy, safety, and reliability when we're in the field and delivering that to our customers. So the benefits are that it's sort of visually accurate to everyone, guaranteed accuracy and resolution when you're operating with automated flight parameters, and it's accessible, transparent, and you can have quality assured data. We see that data can be captured 400 times faster and 6% cheaper than sort of more traditional survey methodologies. And actually today we're seeing a lot more surveyors, like traditional surveyors, moving into using drones as their sort of primary means of data capture, and then using traditional methodologies to sort of fill the gap between what's possible with photogrammetry and what's required in a traditional survey. In terms of how this fits in with active and passive, this format is a passive form of remote sensing, which means that it relies on light being reflected off of an object and taken in by a sensor, i.e. the lens of the camera, to be sort of collected. That light source, typically when you're using photogrammetry for surveying and mapping, is the sun. So you're reliant on sort of like daylight sources and stuff like that, but it also means you can't see into dark areas and shadows, which is one of the sort of drawbacks of this methodology. Here's just an example of what the pilot sees when they're operating the drone. So this is from the SenseFly EB system. And you can see that the flight parameters for photogrammetry are very automated. You fly in nice straight lines, and you can obviously fly at the same height above the ground to get the same ground sampling distance. So you pre-plan all of these, and it sort of follows the terrain and make sure that everything's collected in the right way. I won't go through all of these. This presentation will be available after this, but some of the key benefits of this is fast and cost effective and quick to deploy. You can capture data once and measure multiple times. So that's one of the key benefits of remote sensing in general. You're collecting all of the data available in an area rather than the specific like types of data. So with sort of total station and other methodologies, you're only collecting the data that you physically can get to. Easy to analyze. Obviously, computers can understand it because it's in the computer's language already. Much reduced land access. So you can fly over areas which you may not be able to get access to, and particularly with some of the attendees that we saw saying yes to this in civil engineering, we all know that land access can be difficult, particularly in the planning phase of a project, so pre-construction. So useful for that, and obviously you get zero carbon emissions and much safer. You don't put boots on the ground and in harm's way. Some of the drawbacks: unable to model features that are hidden from view, i.e. in dense vegetation. So the next methodology will come up to that. And then the others there, including sort of sensitive to lighting conditions, and sort of unable to capture features such as rails, curbs, and building features, as it's sort of susceptible to different types there. Here's just an example of a dam up in Scotland. This was captured with the M300 with the P1 payload. So we've got a resolution of about less than a centimetre on this. This is the point cloud image here, where you can see sort of lots of detail even down in this sort of sluice gate down here, which is really great to see. One of the great benefits of photogrammetry is that it's really quick and easy to deploy. And here's just an example of where we have been using photogrammetry to model a site in East London every month for the past 2 years. And you can see the progression of this site over time. So you can see the sort of viaduct appearing in the middle. And this is really what we call like Google Maps on steroids. We're able to update this at a very regular interval and allow people on site to make decisions very quickly and easily, and have informed decisions to reduce the risk on site there. So yeah, again, some of this sort of accuracy statements here, and Ben will fill us in on those. And then moving on to aerial LiDAR. So this is a relatively recent introduction into the UAS industry, particularly, well, I guess the mass market UAS industry. And well, LiDAR has been around for obviously a long time, but it's been available only in sort of manned aircraft settings or large scale drone settings. But we're now seeing the technology become miniaturized enough to fit onto drones that are able to be flown by most people with the sort of basic qualifications. So LiDAR, or light detection and ranging, or commonly known as just laser scanning, uses lasers to precisely measure objects sort of in the distance. And how this is different to photogrammetry is that this is an active form of remote sensing. So instead of relying on a light source reflecting off of an object and into the sensor. LiDAR actually emits its own light source, so in infrared lasers at a very high density, and waits for them to be reflected off of an object. So what that means is that you can control the levels of energy being sent out by that sensor very accurately, and it means you can measure distances very accurately. And a very basic way to compare this is, if anyone's bought or sold a home, is when the estate agent goes around with their little laser pointer that they put on the wall and measure the distances between the two walls to sort of get the dimensions of a room. Laser scanners are doing that up to 500,000 times per second, and measuring sort of those distances and collecting millions upon millions of points every minute in an area. So some of the benefits of this, that you can gather terrain levels even in vegetated areas. You get more details on complex structures such as pylons and cables, and data is actually really quick to process and classify, because the majority of the work has already been done by the sensor. So compared to photogrammetry, when you get images out and you need to stitch those images together and calculate sort of the heights and values via trigonometry. Obviously, we don't do that ourselves, computers do that these days. A lot of the data is already processed and collected in situ with LiDAR. So instead of hours, it takes minutes to process. Again, some of the benefits. So I'll go into one of these in particular on the next slide. So compare through vegetation to get ground levels. So one of the common things that people say about LiDAR is that it can penetrate through vegetation, and I prefer to say it slightly differently. So we say that it can peer through vegetation, because LiDAR cannot physically get through vegetation. It doesn't actually shoot through them. What it does do, though, is manage to find the gaps in canopies and in vegetation, because of this dense field of energy that it's putting down on the ground, and get reflections from terrain levels via that way. So I always describe it to people who sort of don't know how the technology works, as if you're looking up at the sky on a nice summer's day in the woods, and you see all of those bits of light coming through and twinkling. That's essentially what LiDAR is doing, is peering through the gaps in the trees to get to the ground. And what this obviously allows you to do is gather terrain levels more reliably than photogrammetry in those areas. And here's just a diagram of the difference between a digital surface model which is what you typically get with photogrammetry when you haven't post-processed it, and a digital terrain model, which you can get with LiDAR with some very simple classification afterwards. And here's just an example of that in practice. So you can see down here at the bottom, you've got the terrain levels, and at the top there, you can see where it's actually catching some of the vegetation, but you can see the majority of the information is still being collected from the terrain levels there. And that's really the thing that us as surveyors and data capture specialists want to get. The trees and the vegetation aren't really that interesting to most people building things. And then here's an example of how LiDAR can be used to collect more accurate information on complex structures, and sort of maybe like see-through structures like pylons, whereas with photogrammetry it's very difficult to do this. With LiDAR, it's really quite easy. You can see the detail you're getting on them. So with that, I shall pass over to Ben. Ben?
Thank you, Harry. Yes, so we're going to talk a bit about accuracy from a survey point of view, and then related to drone capture. And Harry's got control of the slides, so if you can give me the next slide, please, Harry. Thank you. So the points we're going to cover are what is accuracy. So I know we've got sort of a mixed crowd here today, so we're going to just talk about generally what we're trying to achieve, why it's important, what we can achieve, what sort of accuracies we can hope to get to with these methods, and the techniques we then used to ensure those accuracies and the checks and balances we make. And also additionally Sensat certified, which is a further level that we give our clients for peace of mind and to guarantee what we do. Next slide, please, Harry. So just to sort of talk about the world I came from, if you like, and the sort of traditional world of surveying. So what you might have seen around when you think of a surveyor would be a guy with a tripod mounted instrument like this. So this is like a total station. And essentially what they're doing is gathering individual measurements in an optical way by shining a laser light against an object or against a reflective pole. And they measure angles and distances, and they record normally one point at a time. So it's a very accurate way of measuring. You can get down to a few millimeters, if not better. But it's also quite a slow and intrusive way of measuring. Of course, you've got to have normally two guys there, one on the pole, one on the instrument. You have to walk to each point you want to measure, and you've got to physically be there to do that. And what you would expect from that, what the output you normally get is that image you can see on the right. So that's sort of processed data in a CAD drawing there. So you can see that we've got individual green points, and the guy on site has managed to string some lines between them by some clever coding and what he's doing. But essentially it's a line and point drawing, and that would then sort of be embellished in the office. But there's no context to that at all. It's just, we can see there that there's some trains in the background, and we can probably decipher that's a platform. But if we didn't have those images, we would be guessing at what that is. Obviously, if you've commissioned this survey, you'd hope to know what you're asking for. But you've got no way to know what else is going on around it. And if you haven't asked for it, you haven't got it. You've just got exactly what you asked for, or more importantly, probably exactly what the surveyor thought was important at the time. And he might expect to get maybe 1,000 points if he's lucky, or she, if they're working quickly on an open site. And that's sort of maximum you might be able to get in a day. So that's where we were. That's what we're essentially looking to reproduce for a lot of our clients, or what they used to expect. Next slide, please, Harry. And so this is just a look at the sort of capability. So from a traditional ground point, you can get, ground sampling distance isn't really relevant to traditional methods, but you might get 1,000 points, like we said, accuracies down to a few millimeters. You might cover maybe a hectare in a day, depends on obviously how built up the site is. An open field is a lot quicker than an urban environment, but if you said maybe a hectare a day, that would be okay. And then we move into kind of the drones where we are. So you could expect to cover multiple square kilometers a day. And over a few days, a few teams, you could easily cover 100 square kilometers, which is incredible amount of area compared to what we're used to. Also, we're capturing billions, millions, if not billions of data points. So suddenly we've got all this context data. We've got, not only are we capturing what might be immediately required, the curb line or the fence, but we can see exactly how that sits with the rest of the data, the rest of the ground, the surrounding buildings. We've got all RGB colors to all the data. And so suddenly you've got this rich data set that can be used for multiple stakeholders, multiple applications further down the line. And we're still looking to achieve the accuracies of all those data points to around the 2 centimeter level if we're doing things properly. And obviously you've got then bigger areas, alternative methods, manned aircraft or satellites. So we're just going to think basically about accuracy, just a quick look at this. So this is kind of relative and absolute accuracy. From a relative point of view, we obviously need to achieve both, but relatively accuracy would be the points on an object. So if we've measured points on an object, for example, the house on the left there, we've got we'd expect to be able to take a measurement from the data across the windows, for example, and then go and measure it in the real world with a tape measure and get the same sort of result. So if we're saying we're good relatively to 2 centimeters, you'd expect to have that sort of accuracy on that. Then the absolute measurement would be how we position that in the world, or how we position that in reference to a datum or a coordinate system. So it's okay to have a relative measurement, but then what if I need to return to that point, or what if I need to relate it to existing drawings or some other system? So we obviously need to achieve both of those things within surveying and within what we're doing. We can think about it from the accuracy and precision sort of image on the right hand side there. So this is quite a classic image in the surveying world. I'm sure you've lots of you seen before, but if we just quickly run through it. So the top left bullseye there, we've got low accuracy and low precision. We have many points just scattered around, no sort of way to tell what we're capturing there, where it should be. Not much use to us. The top right image, we've got some good precision now. We're obviously hitting something regularly, capturing the same area, but it's not very accurate. It's not, we can't tell where that is. Is it you know, it's not on the bullseye. So maybe you could say that had some decent relative accuracy, you would hope, but not necessarily absolute accuracy. The bottom left image, we're getting somewhere now. So this is high accuracy, low precision, so not ideal, but we're sort of around the center of the target. If we were to take all these measurements, trying to take as a sort of redundancy, and we averaged them, we'd probably be somewhere on the center red circle there, which would be good. But of course, what we want to achieve, what we need to achieve is high accuracy and high precision. So all the points together on the target and in the same place. So next slide, please, Harry. So the RICS, the Royal Institution of Chartered Surveyors, are the governing body or the sort of overarching body of the survey industry globally, and they've been at it for a while, and they also help out with drone applications, and they give some accuracies in their table. This is taken from some of their releases, and they give two scenarios here. So at a flying height of 30 meters, we could hope to achieve in a best case scenario maybe an X and Y horizontal accuracy of around 1 centimeter and a vertical accuracy of around 1.5 centimeters, which is a sort of typical trade-off, 50% greater error on the Z. And that's with a resolution of, so a pixel, if we're talking about photogrammetry, every 5 millimeters. The next line down is probably more interesting because, so that's at a height of 122 meters. This is the sort of height we're generally flying at Sensat. This is sort of your average site, not having to get special permissions to fly over whatever might be below you, particularly over the public, for example, the sort of getting towards the maximum flying height allowed. So at that sort of height where we would normally be, we can expect to get accuracy down to 4 centimeter level, Z 6, and with a resolution of 2. So this is what RICS have suggested you might be able to hope to get. Next slide, please, Harry. So here's the sort of thing that a typical day at Sensat would be like. So actually is around the 20 to 50 millimeter level in X and Y, 30 to 75 in Z, relative down to, let's say, maybe 8 to 25 and 16 to 50, and resolutions at those figures you see there, 8 to 25 millimeters. So we would look to cover around 5 square kilometers a day with one team, depends on the drone used, of course, fixed wing or otherwise, flying at that height of around 100 meters. RICS give bands if you're not aware of accuracy. So depending on the client's requirements and depending on the end use of the survey, there are different levels of or different bands of accuracy. A very high end sort of fabrication survey for designing some sort of weld might be right down at the bottom end, A, in a few millimeters, whereas something very loose for design would be right at the other end. So we're looking at generally around E to G. This is the typical sort of topographic survey that our clients are after. So sort of large areas of land for design of new roadways or buildings or whatever it might be. And those sort of accuracy sit squarely in that. Next slide, please, Harry. So how do we go about getting these kind of accuracies? The next slide. So from our point of view, we have, so as Harry mentioned earlier, our drones carry survey grade network RTK correction modules. So the data we're getting is pretty decent anyway. But as all good surveyors know, you need some redundancy and you need some independent verification of that. So we collect ground control points that are identifiable within the data that we collect. So you can see that there's a sprayed up point there in that top image. It's also a similar image there of a ground point from the data at the bottom there. So we would collect a certain amount, depending on the size of the site, of ground control points, purely to calibrate the data we have. So obviously if there's any gross errors, we know there's something wrong. We'd expect errors down to around the sort of 40-50 mil mark, compared to the sort of high accuracy ground control points that we've had installed by a surveyor. And we would use, say, a dozen to calibrate the data and to bring that all into line. And we would expect then to get the data down even further to better accuracies to around a few centimeters. We would also then have another set of ground control points that weren't used for that calibration, weren't used in the verification process. And they're independent for later verification. So once we've processed all the data, once our processing team has crunched it all down, we can then go and independently verify that what we've done is still accurate in the other areas of the site, if you like, and make sure we're still getting those few centimeters of accuracy. Next slide, please, Harry. So this is a typical RTK survey grade rover that would be used to measure these ground control points. The RICS gives guidance to surveyors on how these should be measured as well, but we would typically use multiple window sampling over several minutes to expect to get the accuracy of the ground control down to around a centimetre, and they would be done on all those ground control points. So this is an actual report or an extract from one of our reports that we made. So you can see the ground control points that we used listed down the side there. You can see the measured coordinates and the from the drone, that is, and then the process coordinates once they'd been calibrated. You can see the kind of errors that have been adjusted in there on the right hand side on the differences that we've made. And at the top there, so you've got your averaged error, what we're sort of expecting compared to what we originally captured and what was actually measured on the ground. So they're the real-time accuracy of what we've actually measured there. And you can see they're down to around a couple of centimeters. Next slide, please, Harry. So a further stage we use, if possible, this is some data that's we've captured. You can see the point cloud data there that we've created from photogrammetry, I believe. This is actually hosted in the Sensat platform, but Harry's going to talk about that a bit later. We've got the luxury of using that. But this was some sightings we captured for a client of ours. They then later on discovered an existing traditional survey they had, where they'd converted it into the CAD line work. So we were able to add that in the platform for them, and they overlaid it on our data. And as you can see, it fits straight on top of the data we'd collected. And they were able to use that to verify the existing data or see what had changed since they had the survey done. And this is also the sort of output that if you're a surveyor, you know, that a lot of clients are expecting. So this can then, on the other hand, be extracted from the data that we have. We have CAD teams that can create this sort of line work CAD drawing if our clients require it as a further deliverable. Who to trust? So just to talk about Sensat really, and from my point of view as a surveyor, I've obviously come on board to make sure that we do things to meet those standards that we've just talked about and those accuracies. And there's no reason you can't do that. I think I see it as a tool as a surveyor really, rather than the other way around. So I don't see it as a drone pilot trying to create surveys. I see it as surveyors using drones to capture data in the most efficient way. And there's no reason that can't be done. So with the right kit, the right survey grade drones and payloads, the right checks and balances, then you can create survey grade data and you know, quality surveys using drones. I think what you need to bear in mind is that there are those checks and balances, and we have specialists in our processing teams. We have the people like me, we have survey grade payloads, we have the drones with the survey grade RTK, and we have all these quality checks down the line to ensure that we are delivering those accuracies that we say that we will.
So a question from the crowd here, Ben.
Yeah.
Can surveying completely replace the need for traditional ground-based surveys? Or can aerial surveying, I think they meant.
We find no is the honest answer. It probably depends on the site. So if a completely open site with nothing hidden away, then yes, of course you can. But at the moment, even with LiDAR, there's always going to be something that we sometimes can't see. So the typical example would be a culvert in a ditch that's been sort of flooded and a pallet has washed along the stream or the ditch and sort of covered it all over. The client needs to know the invert level on that culvert. There's no way that we can get that without physically going in there. And so we see it as maybe, you know, covering sites in 95% of cases, but occasionally there's a need to send in someone on the ground to capture that little bit of detail that we couldn't see. But, you know, from our point of view, we're open with the clients about that from the word go. Most of our clients aren't looking for that level of detail, maybe from the word go. We're able to very quickly get them a sort of massive data set, highlight to them where there might be sort of some details that are obscured and maybe even need cleaning out of the way first before even a ground team can get in there.
Yeah, I think people are using it sometimes as a bit of a gap analysis, particularly in high risk zones like road and rail. So instead of putting boots on the ground to do the whole thing, you use a drone to do everything and then pick the areas where you want to put terrestrial teams in, or use other methodologies such as like laser scanning or mobile mapping. Do you want to run us through Sensat certified quickly, Ben?
Yeah, so just really this is the culmination of everything we've just spoken about, and it's just another layer that Sensat guarantees to its clients if it's required as a service, so that we can, you know, we have all these reports and we have all these checks and balances, and it gives our clients peace of mind that what we're producing is at the standards that they're expecting from their specifications. It's back to you, Harry, I think.
Yeah, absolutely. Thanks, Ben. So I'll quickly run through these and then go straight into the platform demo, because I've seen a few people asking questions about what the platform was that we showed and stuff like that. So I will run through these. So what Sensat are doing is automating the way that we all plan, bid, build, and manage our construction and infrastructure projects. So what we want to do is de-risk these projects as much as possible, allow people to make decisions quickly and move forward rather than having to wait for data to be collected to make those decisions and de-risk these projects. Literally just yesterday, I got a data set in for a port project in the bid phase. The bidding contractor came to us and asked a few questions, blah, blah. They sent me their bathymetric data and it was inverted. So what we were able to do is actually see that on the platform almost immediately and then tell them that that data was inverted and make sure it was edited for them. So during the plan, bid, build and manage stages, obviously the use cases are slightly different, but I really think that this quote from Thomas Whitting at A Modal, who are working with British Land in East London. So he said, I pay Sensat for cost certainty. It doesn't matter because the cost of reworks and mistakes would far exceed the initial investment. It's much better to mitigate those risks by having better information early on. And on that British Land site, we're doing monthly surveys for monthly data capture for them. And what they're using that to do is essentially go into their project, see where changes have been made, and ultimately make decisions that de-risk the project going forward. One of the specific examples there was that they had put some hoardings up and got the design of a building which were causing a major pinch point on the only access road on and off of the site, and it was already quite a narrow access road, and it basically made it impassable by HGVs. So by catching that early, by seeing the designs compared to the sort of terrain, they were able to mitigate that, redesign the sort of asset and go forward before having boots on the ground, probably saving them tens of thousands, if not hundreds of thousands of pounds if they'd caught it when the project was in full swing. So I was going to the the Sensat demo here. Can everyone still see my screen? I think you can, can't you? So this is the Sensat platform, and I'm going to show you a couple of demos here. One of them being sort of a rail demo, which is in Leeds, and one of them being a highways and energy demo. So this is our platform, which has 3D and 2D capabilities, and essentially allows you to ingest all of your survey and remote sensing information into one place to enable people to make those more informed decisions and de-risk their projects. It's not specifically designed for drone data. Obviously, it does very well with drone data, but it can just as easily be incorporated with like mobile mapping, laser scanning, or even just traditional survey data. What we find is that this platform enables both non-technical and technical users to access information that they wouldn't previously have been able to on site. So it sort of not homogenizes it, democratizes that data across all teams on a project. So I'll just give you a little tour around here. So the first thing you'll notice is how quick and easy it is to use. Very similar controls to stuff like Google Earth or your other CAD projects. So you click and drag to move around. I will slow down a little bit because I realize this is a screen share. So you can, as you can see, this is drone data here. So this is UAV data. You can go all the way down sort of to track level and see details on everything there. And you can also zoom all the way out and see sort of the whole picture down here. As I said, you can always also combine different types of data together. So actually, if I zoom down here, what you'll see is actually our team used terrestrial laser scanning to capture the underside of this station. So we're able to actually go into this area here and see in a very high amount of detail sort of the underside of the station. So this is an area where obviously drones would not be able to traditionally capture data, and you wouldn't typically use them. So we've used terrestrial scanning to capture that data instead. And with terrestrial scanning, you're able to get sort of much greater levels of detail on things like curves, as you can see here, and start using them to make decisions as well. On the left-hand side here, you've got a few tools and sort of abilities within the platform. So you've got some tools like the point tool, which you can use to create sort of points of interest. Typically, we call these markups, so that it can either be used as measurements or to communicate information between different users. So we can see this here. So if we want to communicate that with someone, so immediately that becomes a bit of a point of interest. We can also add sort of different annotations to this. So let's make sure it's red, and we can also share that with the project and make sure that everyone on the project can see it. Another way these can be used is to communicate different hazards or information on site. So if I go to, actually, if I go to this, there was actually nice in the 3D, 2D, isn't it? So for instance, if I wanted to do an area markup, I can just actually create a zone here, and that will allow me to sort of mark out an area which we can say is going to be for different purposes. Messing around, doing a live demo here. Why won't that allow me to click that? I'll try another one. So maybe if I do a line tool here. No, yeah, there you go. So I can put some information here. So say like access route. And I can actually put a time stamp against this. So actually, if I want to put an end date on that, maybe the 30th of March, if that access route was only going to be available for the next 8 days, I can do that, and I can communicate that with my team by putting that as a date line. So if I go to the timeline at the top here, if I go to April now, you'll see that actually disappears. So you can start creating stories and stuff like site inductions or safety briefings using this tool, and enable teams to really create sort of time sensitive information. This is also applicable to designs and any other data that you put into the platform, so you can time bound them. So for instance, if you had a design review meeting every week, you could make that design only sort of applicable to that week, and then the next week it disappears and the new designs come in. One of the latest features in the platform is the commenting tool. So what we're able to do is use the commenting tool to communicate directly with other people and actually tag different types of information in here. So we can actually tag sort of other people. So I can tag Zach here and say, see the access route. So we've got that one. This is for March only, for example. So if I send that, he will receive an email in his inbox, and he'll be able to click on a link and come straight to this comment box here and see exactly what we're looking at as well. A tool for the sort of more technical users who use other platforms is the crop functionality. So you're able to use this to crop out certain areas of data. So if I just wanted to crop out these sort of 2 Gantt trees here, I can do that. And what the platform will do is enable you to sort of crop those, and it'll give you a file to download, which is obviously a much smaller size than the overall size of this project you're seeing here. And my favorite tool, actually, if anyone's ever been in meetings where you've been using Google Earth, you'll appreciate this, is the viewpoint tool. So viewpoint allows you to zoom into an area, say this area, which we did the markup in, and create a unique point of reference which you can share with other users. So you can either share it by adding their name, so I could use Zach again, or I could use the link, and you guys won't be able to access this, but I'll put it in the chat anyway. So if you clicked on that link, you'd be taken directly to the view I'm seeing here with the exact same data and the exact same markups that I'm seeing as well. And if you want to sort of reset your view, you just do that, and it will take you to sort of the bounding box of the area. In the 2D, very similar to sort of other GIS mapping sort of softwares, you've got similar tools up in the left here, and you can sort of move around quite freely. As you can see, with the drone data, you're able to go down to a very high degree of accuracy. I often call this sort of Google Maps on steroids. Back into the 3D, I'll just show you the layer panel. So we're also able to overlay CAD into these areas. So you can see here that the topographic CAD has been overlaid into the point cloud information, or the 3D arena. And for those of you who don't typically use CAD products, this is pretty much a game changer. You don't usually be able to do this with so much freedom and ability to move around. It's very difficult to combine even 2 CAD files together, let alone a CAD file with a point cloud file, and then also with a 3D mesh file, which is hidden behind this building here as well as sort of, as you can see, the laser scans over here. So if I go over here, you can see this obviously combines with the laser scans we've got in this area as well. It's going to quickly nip over to another project now. So this is a demo project for some energy and highways. So this has got a few more markups in it, as you can see, and also a few more CAD objects. So you can see that you can overlay designs in here. So these obviously aren't real pylons here. They're designs of new pylons which could potentially go in to support the project. We've also got another type of aerial data integrated into this one. So this is aerial LiDAR here combined with photogrammetry. So the wider area you're seeing is photogrammetry, and then we flew aerial LiDAR over these pylons. And what you can immediately see is that if I turn off the LiDAR here, you'll see that the quality you get from photogrammetry compared to the LiDAR is, well, basically incomparable, particularly on the cables and on the structures here. Again, if I turn that off, you can see you're not getting much detail on the structure and the individual elements of that structure with photogrammetry, and with LiDAR you're able to get much more detail there. And then again, you can overlay your designs. So this is a solar project. So this is an example solar project where they're able to overlay their designs for this asset into the real world environment, and essentially take their sort of decision-making process from weeks down to days, and see all of their constraints as well. So it really gives you the visual context for how your asset's going to look from anywhere really. So if you wanted to go down here, maybe to the footpath that's down here, you'd be able to see that. You could go to other people's buildings as well. And finally, just in the 2D here, you can see how like more GIS information can be overlaid to give you some more contextual data. So you can see here that these red lines represent gas mains. So these are large gas mains operated by National Grid. Interestingly enough, you can see from the photogrammetry there's some sort of disturbance on the ground actually, so you might be able to guess that they're there. But this is a really major problem for the industry. Utility strikes cause millions of pounds worth of delays and damage every year. So having this information at your fingertips is really important. And other things like sort of ancient woodland and other things like SSIs enable bid teams to more accurately sort of manage their bids as well. One thing I didn't mention is that this is obviously all hosted in the browser, so there's no need to download any information or softwares. You can access it via your laptop, via your iPad, or even via your phone as well. So this information is truly sort of available to anyone, anywhere, which is a big step from where we've been previously. So with that, I will hand over to, well, I guess Ben and I, and answer any questions that have come through. Has there been any further questions?
There's been a few. One that's probably better for you if you can answer it, Harry, is
Yep.
What challenge you experience when it comes to drone licensing from the aviation authorities?
So I guess that if I went back to my presentation here and went back to this slide here, the sort of challenges we face with the Civil Aviation Authority in the UK and then also globally kind of follow this same these same timelines. When like drones were really starting to come in, they were really playing catch up. But these days they're a pretty slick operation, particularly in the UK. And with like sort of the standard permissions, they've matured a lot. I think we've probably entered into a mature market for regulations. We don't really see too many opportunities we have to turn down because of the regulations, and I think they're there to be safe and make sure people are operating these drones correctly. So I can't speak for globally. However, in the UK, which is the Civil Aviation Authority, are kind of one of the gold standards globally for aviation regulation. I think over the last 7 or 8 years, it's really developed quite a lot to a point now where it's I'm pretty happy with it.
We've got another question. Does the platform process the raw data?
So the platform does not process. I assume you're asking whether it processes it from images through to the point clouds and the other outputs. So our platform doesn't do that. However, we've got a processing team in-house which can do that if you're unable to. So if you want, you can get in touch and we can organize something there. With that, you'll also get the same verification methods as we can offer as well. I think there's one more question there about BVLOS. Are we looking to operate BVLOS operations in the near future? So we're actually one of the first, if not the first operator in the UK to run BVLOS. So back in 2017, we were part of the Beyond Visual Line of Sight Pathfinder, so the first one of those, and we also followed that up with the second project. At the minute, BVLOS doesn't offer a commercially viable prospect, i.e. there's a lot of planning that goes into each operation, and we at Sensat are very sort of reactive, so we can be on site within sort of 24 hours of being asked. So beyond visual line of sight doesn't really help us too much today with the regulations as they are. However, with technology such as drone in a box coming through from DJI and other sort of technologies for detect and avoid, I see in the next couple of years that is probably going to be changing.
Great. There's one other, as we're at the end, which is maybe best for you then, Elena, which is the presentation recording available? If so, where?
Yes, the presentation will be available as a recording probably from early April at the moment. Give us a chance to finish off this CPD session, and then we will upload them all and make sure that they're all available. We will contact everyone who has originally signed up for these CPD sessions and let them know that they're available, and also probably do a bit more marketing around it too. I think that's probably everything. I think we've gone over by a couple of minutes, but given that we started a couple of minutes late, that's probably pretty easy. Thank you very much, Ben and Harry. That was fascinating. I found it fascinating the first time, and there's always yet more detail to appreciate, and how much skill and talent goes into this. I know that Harry and Ben have included their email addresses here, and that I know they're also available to contact via LinkedIn. And we are I can certainly, and we are contactable via email at membership@arpas.uk. Thank you. Oh, hang on, I'm just seeing there are a couple of emails, a couple of questions still open.
I think we answered. How do I get access to the Sensat platform? Get in contact with us and we will point you in the right direction, or the website will also point you in the right direction as well. But happy to field any questions personally. Yeah.
So I think all of those then have been answered. Oh, hang on. Yeah, all been answered. So that is good. Thank you very much. And the last one, which is here, is there a register of operators? Certainly via the ARPAS website, we have a find a member section where you can find people who are registered with the CAA. There are a number of questions you obviously need to check with people, that they have the appropriate qualifications, the appropriate insurance, and talk with them about the data that they can provide, and that you have the appropriate facilities to be able to watch and look at the data. Thank you very much indeed. And if anyone wants to attend any more of the CPD sessions, please have a look on the ARPAS website, www.arpas.uk/CPD. Nice and simple. Thank you, Ben. Thank you, Harry. And thank you everyone for attending too, and taking your time to do so. I think we shall finish there.
Cheers, guys. Thank you, everyone.
Very much.
Bye-bye.
Bye-bye.